Let's go. Yo, I'm like an addict, do I gotta have it. I ain't even playing, got a really bad habit. If it moves, gotta grab it, fuse like a magnet. Lose, won't have it till I'm doomed in a casket. I ain't playing, got a weird mind. If you work 8 hours, I'm a...
Hey, morning. So we're heading into Boston this morning to Autodesk Technology Center. So we should be in for a pretty good ride today. Alright, here we go. Alright, so we just arrived in the Boston airport and we're about to head to Autodesk Technology Center. So catch you up. So we are here at Autodesk Technology Center.
I take shots to the top, I'll get it. I got one life, I'ma do all to win it. I do what's right, pushing till I fall, I'm slipping to get back up. Always stand tall, I'm grinning. I got cuts real deep, big bruises scarred. I had to learn how to think with my head not hard. I've been chewed up, spit out, torn apart. But picking up all the pieces is a form of art.
I'm never gonna look back, cause damn, I was built to last. You move slow and I move fast, and that's facts. Only I can make a change, slowly take a step today. I will never be the same, cause that's what it takes.
Well, where do we start? Alright, I'll give you the tour that I usually give customers to give you an idea of how we pitch the space and what we talk about.
Okay.
You know, a lot of folks ask when they come in, it's like, well, why is a software company doing this? Why you build software, why are you building these facilities, ins and outs, these spaces with teams as a house? And, Bruce, what's the reasoning behind it? There's really like 4 reasons. Do what it's supposed to do, and these places allow us to de-risk that for our customers. So we do internal validation, we do education, we understand what works and what doesn't work, and we give that feedback to our product teams and developer teams. So that's really the first piece, is kind of internal research and validation. The second piece is to kind of understand where industry is going. And the last thing we wanted to do is, put a bunch of Autodesk people in these workshops and, tell us what's next in the industry, because we don't really know.
Right.
The startup community understands, the academic research teams, kind of engineering teams understand where industry is going. So we have residency program on the second floor where we invite outside teams to come in and use our spaces. They use it free of charge. There's no strings attached. We don't take any IP, we don't take any equity. So they really have the opportunity to operate freely.
Wow.
And we're software agnostic, so we don't require people to use Autodesk products. They can use whatever they want. And it really gives us an understanding of why they're using maybe a competitor's tool or how they're using our tools. And oftentimes we'll like to couple an internal Autodesk research.
3,600 square feet.
So 18,000 feet down here, 18,000 feet on the second floor, so about 36,000 between the 2 floor plates.
Okay.
The basic layout of the workshop was to have an open workspace in the center and workshops on the periphery.
Got it.
Having the open workspaces gives us a lot of flexibility for different teams to come in, different durations of stay, different configurations. We can do, bigger projects, smaller projects. This facility was commissioned in 2016, and at that time we were part of our construction and architecture division. So we wanted to be able to have the ability to do architectural scale projects. So the space is inherently bigger. Our machine format is settled on a 5 foot by 10 foot, 5 foot by 10 waterjet, you'll see, by 10 router. So we wanted to be able to do larger construction style projects.
Question for you, what type material would this be?
This is PETG. Okay. This is a recycled PET product that we did. And this was a 5 meter print, 5 meter bridge print that we did. You can see the video there.
Right, I saw it.
And there's the robot that did it. It took a lot of time to figure this out, but we ended up working on it for about a better part of a half a year. We did everything in Fusion. We even drove the robot in Fusion. The internal lattice work is all generated design, and it was featured at AU last year.
So this material, what type of structural integrity does this hold?
That's a great question. So they did do structural analysis within Fusion. It's for pedestrian. It's pedestrian rated right now. What we also did was, you'll see the DeWalt router on the end of the tool as well. We routed in grooves to put strain leaves. So when a person walks over the bridge, we get a force signature, and we start understanding kind of the life of the bridge, what's happening with it. We get that, we grab that data, feed it back into the model, and if we were going to do another one, we would take that data and probably modify the design based on that data.
So at present, is this the best finish in terms of surface of
What
it?
we could do right now obviously you could mill that and you get a better finish if you wanted to mill the entire surface, that's possible. But you can see having this finish, it allowed us to get it done in a timely manner. It still took quite a while. We were able to get it done very quickly.
And it has a little aesthetic value to it also.
Yeah, absolutely.
So,
It's pretty interesting. This is a 3D print of the actual bridge part that we did that was featured at AU. This shows the internal lattice work underneath, the outer skin of what we did. And this was printed upstairs on our Mamaki printer.
nice.
Yes. Did you have a water jet on the first floor?
We don't. So this is new to us, really.
Okay. So the water jet, forgive me if you already know this, but the water jet, we have a pump in the other room. It's an intensifier pump that generates pressures up to 87,000 pounds per square inch. And it forces it out of this 40,000 diameter nozzle. The water actually doesn't do the cutting. The cutting is done by a small stream of garnet or aluminum oxide that gets introduced into the water stream. And that abrasive action actually does all the cutting. The beauty of the process is that it's cold. It's a cold cutting process, so you don't have a heat affected zone. You don't change the material properties at all. You have to cut like you would a laser or a plasma cutter. It also gives you...
Does that material filter back out?
The material just drops in the catcher's
So
tank.
it's just a waste.
Yeah, so it drops into the tank every 6 months. We have basically like a sewer pumping company come in and they pump out, they muck out the garnet and it gets recycled. So that's how that goes there. The beauty of the machine is you can do multiple materials. We've had granite, rubber, obviously multiple types of steel on here. Can't do tempered glass because that tends to blow up on you, but it's very, very versatile.
What's the maximum thickness of cut?
This particular machine can cut about, depending upon the material, anywhere from 12 to 18 inches thick metal. So 12-inch thick Inconel. They've had, this particular machine has done up to 16 inches of titanium. It does it very slow, but it's able to do it. The machine also has a full 5-axis capability, so it can cut in 3D and do it in 3 inches. So super versatile machine, one of the most used machines in the space because it's just saves so much time. Something you might machine or drill, you just throw it in the water jet. And your accuracy is right around 2,000 or 3,000. So for basic roughing in, it's a great machine.
I take it this would be like the larger of the models available, right?
Yeah, this is a bit on the larger side. There's obviously even larger models than this.
Oh yeah.
But if you're considering getting a water jet, let me know because I think it's a super useful machine. The head compensates, there's tilt compensation for curve because as physics would have it, when the water jet comes out, it tends to go out, but the head actually tilts in and comps for that, so you get a nice straight cut.
Okay.
Do that.
It's a clean cut too.
Yes, it is. Yeah. Very clean. It's one of the most, do a larger format project, or we want to have it interact with maybe some robots.
We just want to do limited welding.
Yes.
What do you recommend, MIG or TIG?
Both.
Oh.
I do, because if you could only have one, go MIG. Go MIG. Because MIG is a super versatile welding process. It's very easy for new users to learn on the MIG machines. Something like a Miller mat, like this one here. This is a 350. It's probably a little bit bigger than you need, but they have a 250 that's probably a great size. We have a 250 that we just commissioned up in Toronto, but this Millermatic machine for MIG welding is fantastic. If you want to get into TIG welding, I recommend like a 200 amp Dynasty series TIG welder. Again,
with this machine though, we don't need this, right?
this machine you do need gas.
Oh, you
don't have to.
Okay.
You can use an inner shield wire that has a flux core.
Right.
However, that's a very dirty weld, and you gotta
chip it off.
slack.
Yeah.
This is a very clean. Portability is huge.
I'd like something that's slightly bigger than this one.
Yeah, absolutely. Yeah, for sure.
This one has a laser light on it.
Yes,
also.
it's got the laser on it. Evolution Tools is a really good brand. I'd recommend them for any kind of metal cutting applications. Have been great for quick stuff. Used for very thin, detailed sheet metal parts, which you can do, but it's kind of like driving a tack with a sledgehammer. It's just not the right machine for it. So we brought this laser on to handle kind of 1/8 mild steel and thinner. And this machine is much faster, much easier to run for that. So that's what the purpose of this laser was.
Okay.
of one another or run together in tandem for larger format projects. We use this a lot for doing foam work, for doing composites mold, we do a lot of woodworking with it. We can cut aluminum with it as well, but we do it very, very slow. Yeah, it's not made for heavy milling, it's made for lighter routing, lighter parts. We put all of our shops in rooms, and we did that for a couple of reasons. One of which was acoustics. When that thing is running, it's pretty darn loud, right? It's cutting material high speed. The other is dust control. That machine can make a tremendous amount of dust really fast when you're really hogging a lot of material out. So you see on the right-hand side, those white columns, those are actually filter socks, and that's a dust collection system that's relegated to that room. So what it does, it takes a flat coil of steel, like those coils that you see there, from the feeder to these 6 hydraulic punch tools, and these 6 tools put different features on the studs, whether it's a hole or a dimple. They'll do pass-throughs for utilities, things like that. And then once that process is done, it puts it through these 6 incremental roll formers, and then it runs it down through the process to the final shape, and then it has a printer that prints the part number, orientation of or whatever the piece is, and then shears it off. And it's tremendous what you can do. I mean, these parts are going so fast. This machine spits it out really quick. You can build structures from. Use that to build the bridge. We also use that for larger construction projects. So real flexible with having the machine on the track. Other robots, you'll see that we put on these weld plates, and that allows us to reconfigure a robot cell relatively easily. This is an 80 kilogram capacity robot. We can reset the cell in about a day's time with safety. So there's a lot of flexibility in how we do our operations. We have overhead area laser scanners for safety. We also can put on hard guarding. There's a grid throughout, you can see too, there's a grid of holes throughout the space that allows us to put polycarbonate guards up.
It's a big chop saw.
Yeah. So this is our precision shop. This is where we do all of our milling, turning. We have a big mix of machines from manual to CNC. So we have an old school bridge board, old school along. We train our users up. That's where they start. That's where they learn. And then we bring them solely into the digital side of things. We have a Brother 5-axis machine that Zach's working on right now. We have a Haas BF5 SS. That's 3-axis, but it has the 4th and 5th axis in it. And then we have an SD trolley washer. Tool grinders, drill presses, press, mini mill in the corner. We use this bandsaw for cutting material, but also separating 3D prints from our Renaissance printer. We have a fixture just for doing that. I want to see what he's doing over here. We just commissioned this machine.
Could you explain some more about what's happening here?
Yeah. So Zach's doing a 5-axis part right now. He's milling some aluminum at high speed. This is a Brother Speedio. This is a very high-speed machine. He's not pushing it anywhere near as fast as it can go, but he's just doing a surfacing operation right now. We're really doing an acoustic study because the machine's pretty loud, and some of our neighbors are complaining about the loudness of the sound. So we're trying to see what we do to quiet down. How's it going, man? So we put those feet on it to absorb some of the acoustics that will, because it's a cast in place concrete building, all of these sounds transfer so easily. You know, if you're hammer drilling two buildings over, you can hear it. This is just no noise at all.
This is the stubby tool.
So this is the finished product. These were milled on the CNC mill currently in operation right now. It's a removal process. But this would be your finished product.
counts as that brick.
Okay. So we move from here to here. Awesome.
Just a quick 2 hours.
Yep. All right. Thanks, man.
Yeah.
All right.
Resin-based additive machines like the Form Labs, as well as a couple laser cutters in here, and then robots like that. So these two Fusion Epilogues are 120 watt CO2 lasers. Again, very popular machine because it's easy to use. You can do acrylics with it, you can do engraving, lots of wood, cut fabrics with it. So these are super popular machines, and they run very, very well. And it's kind of some of the first, next to a 3D printer, I think it's kind of the next machine that people get used to and try in workshops. So these are really good machines.
So big bed.
Yeah, it's a good size bed. That's good. 36 by 40, I believe is the size. So yeah, it gives you a lot of good options. And you can actually put the doors out the side if you want to put a bigger part. You can do it from the side too.
Oh, okay.
So we have the full mouse. Yeah, we had fantasies. But this is what the Mamaki is capable of. So it can do all of these beautiful colors. This is a scaled down version of a metal print that we did with GE for this engine, but it shows you the internal lattice work. It's kind of a see-through, but you can see all the different colors that you can do with the Mamaki. So really cool printer. Lots of capabilities. Maintenance intensive.
Exactly.
Maintenance
Yep.
intensive.
Must
As
take
you know,
a long time.
It takes a long time.
You have to clean each jet.
Yeah, there's all of the cartridges are lined up in there. There's a
And
pump
the
and
problem I
everything.
have with it, the resin, they expire too quick.
It's very expensive.
And
The total cost of ownership for any type of this processes like these out of the processes are extremely expensive.
Right.
So we have a smaller version.
So this is a powder metal 3D printer. This is a
Oh.
Ramshaw AM500Q. And I'll show you. I don't think we have a prop running, but I'll show you the basic idea. Yeah, it's off right now, so it has a build plate inside, and it takes a thin layer of metal powder with a coater, and it coats the plate with that thin layer of powder. Then there's 4 lasers, 500 watt lasers that come down and start melting the part layer by layer by layer. Very fast machine because it has the 4 lasers. We're currently charged with stainless steel right now. That's the machine runs all stainless parts right now. This machine is not available to the users to run, so only my team runs this. It's kind of a service provider thing. So they'll come to us with a file, we'll help them get the file prepared for printing, and then we'll run the part. We post-process it because when the part comes out, oftentimes it's full of powder, so it goes into this depowdering station here. It's basically a build plate, and it has a vibrating mechanism that vibrates the whole plate, and then you can rotate it from X, Y, and Z to get all the parts out. And then you have a couple of blowers and a brush, and you feed, and it's in an inert environment, so everything is safe because powdered metal is hazardous, it's flammable. So this is all handled in this particular machine. That's where we do any kind of sieving. This also has our high explosion-proof vacuum cleaner as well, so we have to do any vacuuming operations in the machine. So this is a whole nother level of safety and code requirements just for this room. This machine was the first one of its kind in the city of Boston, so we had to work with Boston Fire and our code consultants to get all the rooms in order. So the gas chambers here feed the machine, and then this chiller cools the lasers. So this is a dedicated chiller just for the laser system.
So after the build, does the part have to sit in the machine for a while?
Not usually.
Okay.
Yeah, not usually.
So that sintering happens
all
In
in
the
one.
process, in the
Yeah,
process, okay.
so you're on your studio machine, where you build your part and you have it in the green state,
Right.
Then you take it over to the oven to get sintered, and you get the shrinkage, all that. None of that. You don't worry about shrinkage or anything like that. It's all done here.
Got it.
That type of stuff could never be done on a subtractive process. So that is really only capable with a machine like this one.
So this was done on the metal printer machine.
Yeah. We were concerned too when it first came in. It's like you got a container of powder. Is it really solid when it gets full all together? So we did this print and then we post machined it to give you an idea of how it's solid. It's all there when it melts together. We machined it off, and then we gave it a little polish to see. There was no inclusions, no porosity, so it's a pretty impressive machine for sure.
And this vessel also?
This is plastic. Yeah, we got a couple of different pieces. Yeah, this part here was done in titanium.
Okay.
This has some general design lattice work, to give you an idea of the weight of the parts. Yep, this is an F1 part that we did a little while back to look at comparisons between materials.
It's like a hub right here.
Yeah, exactly.
Oh, well, it feels like 3D printed metal.
Yeah, it's plastic there, because this one was done in stainless, and you can get an idea of the weight on that, and this one was done in titanium. So this isn't tied, like that, right?
Wow.
That's pretty crazy, right? That's
And you're getting some good strength capability.
yeah, absolutely. You can see all the internal lattice work that was done.
This has the same internal lattice structure.
I believe it does. Yeah, I believe maybe some of the, maybe in some the altimeters, and we've just started to commission the bamboo printers.
So these were the ones you're suggesting?
Yes, these are the ones. These are fantastic machines. They just run and run and run and run.
Yeah, two of these.
Yeah, the altimeters are decent. They're not a bad machine at all. But these bamboo machines are, for the money, you can't beat them. They're very economical and they're fast. And we're starting to shift. We're starting to shift a lot of our food over to the bamboo printers now. You know. So we just got this. It's a brand new machine. We just got some EH&S approvals yesterday. So we'll be running at a little bit later on this week. I don't know. I think this could be this. I think they just released me. You can see you get a lot of use of that. They placed this machine here for us to kind of try and use. So we've been, we work with them. It's not perfect. And we work through them with their workflows to try to optimize it and stuff like that. So we give them good feedback. They have access to the printer, which is a win-win for us. Space rounds out with a kind of a training meeting room area, a town hall setting. So you have a small stage. We can seat about 80 or 90 here. We had Mayor Wu in a couple months ago with our CEO Andrew Adnos. So this is places where we do some larger conference rooms and conference settings. You're in the technology center, but you're also in a customer briefing center at the same time. So this is kind of where we have all that.
Where all the big decisions.
This is it, right? This is where it all happens. So everything's Zoom roomed and big screens, and so it's very wild.
Very nice.
Yeah.
Your headquarters in San Francisco.
We're in San Francisco. Headquarters in San Francisco. I'd say, yeah, exactly.
Yeah, I've been there once.
Have you? Did you go to One Market or the Pier? Pier 9. It's Pier 9. Yeah. So.
Up all the pieces is a form of art.
I'm never gonna look back, cause damn I was built to last. You move slow and I move fast, and that's facts. Only I can make a change, slowly take a step today.